Hello, my name is Laura Mirko. I'm a clinician at the Implant Dentistry Center in Boston. In this video, I will demonstrate the use of a seating jig for the insertion of universal abutments with milled retentive copings for a TRINIA telescopic prosthesis. Following this demonstration, I shall share with you our experiences of 5 clinical treatments using TRINIA telescopic prostheses. Initially, when we first fabricated fixed TRINIA bridge restorations in 2010, they were designed to be intraorally cemented prostheses. However, because of irretrievability, hygiene, and extraneous cement issues, we moved to various materials and techniques for custom telescopic copings. Fortunately, with the availability of the universal abutments in 2015, we were able to design and mill standardized titanium copings, which have provided us with a more efficient and cost-effective way of fabricating TRINIA telescopic prostheses. A minimum of 3 red-colored retentive copings or metallic-colored non-retentive copings are used for the fabrication of a telescopic TRINIA prosthesis. The copings marked with a 5L are specific for the 5L or 5 low-profile universal abutments, and the unmarked copings are for either the 5 standard profile or 5T or 5 tall profile universal abutments. If the retention of a set of copings is too great, replace one or more of the red-colored retentive copings with one or more of the metallic-colored non-retentive copings. Alternatively, if the prosthesis is too loose, replace one or more of the metallic-colored non-retentive copings with one or more red-colored retentive coping. Their use almost always eliminates the need for custom copings, allows for a precise marginal adaptation to an abutment, eliminates the need for intraoral cementation to an abutment, and facilitates gross adjustments of the TRINIA prosthesis. This is because the intraoral resin cementing of the coping to the TRINIA prosthesis readily fills any voids between a milled coping and the TRINIA prosthesis. The following demonstration and clinical presentations should provide you with an understanding and appreciation of the clinical use of milled titanium copings and universal abutments for telescopic TRINIA restorations. The prosthetic restoration with a TRINIA telescopic prosthesis begins with the making of an implant-level transfer impression with red, blue, or green color-coded impression posts and sleeves, specific respectively for the 2.0 mm, 2.5 mm, and the 3.0 mm implant well diameters, and for the fabrication of a stone model with implant analogs. After the stone model is fabricated, appropriate abutments are selected to provide for their prosthetic portions to be as close to parallel as practical. Then, red-colored retentive and metallic-colored non-retentive copings are placed onto the universal abutments prior to their being digitally scanned. After the scanning, the TRINIA substructure is designed as a bar for use with candelar teeth, or anatomically for use with handcrafted custom teeth with a polyceramic material such as ceramage. It is essential that the substructure design provides for a minimal occlusal thickness of 2.0 mm of TRINIA material over each coping. After the milling of the TRINIA substructure, candelar composite denture teeth are attached to it with cyanoacrylate glue prior to the characterization of its gingival anatomy with a polyceramic material such as ceramage. With the prosthesis completed, it is incumbent upon the technician to fabricate a light-cured resin seating jig to non-verbally communicate to the dentist the sequence and a means for inserting the abutments into the wells of the unlikely parallel implants. The two most prosthetically parallel abutments are chosen to be the first abutments to be seated with the seating jig. Once the first two abutments have been successfully seated in their implant analogs with the seating jig, their position is numerically marked on both the seating jig and the stone model with the numeral 1. Additionally, the facial groove on the universal abutments is marked to facilitate their appropriate positioning. This process is continued until all of the abutments have been seated. To facilitate their seating, the abutments are only partially seated into the bores of the jig. Prior to being seated into the implant wells, Vaseline is applied to the bores of the seating jig to facilitate the jig's removal from the seated abutments. Initially, placing an abutment loosely into the well of an implant may be necessary to use the seating jig for the abutment's final alignment and seating. This approach is indicated by an arrow marked on both the resin jig and the stone model. Occasionally, a crown remover device may be necessary to remove the jig from the seated abutments. By gently tapping the newly placed abutment along its vertical axis and that of the implant should assure it is fully seated. Rarely, it may be necessary to use the actual prosthesis to align and seat an abutment. After all of the abutments have been definitively seated, the TRINIA prosthesis is placed onto the abutments to confirm its appropriate seating. Subsequently, after the placement of the copings onto their respective universal abutments, the prosthesis' appropriate seating should be confirmed once more. If necessary, any modification of the TRINIA prosthesis should be done prior to the resin cementing of the prosthesis onto the retentive and non-retentive copings. Once all of the abutments are properly seated, Vaseline is applied into the bores of the milled titanium copings prior to their placement onto the universal abutments. This facilitates their removal from the universal abutments after their cementation into the bores within the TRINIA prosthesis. Also, prior to applying any resin cement, coat the underside of the prosthesis with Vaseline to facilitate the removal of any extraneous cement. Resin cement is then applied into the bores of the TRINIA prosthesis, and the prosthesis is gently inserted intraorally onto the milled copings. The resin cement will mechanically attach to the circumferential grooves on the milled titanium copings and to the TRINIA prosthesis. Without moving the prosthesis, wipe away any extraneous cement and let the resin cement set for 4 minutes. Upon removal of the prosthesis, any extraneous cement is removed. The telescopic prosthesis is now finished. Should the retention of a TRINIA telescopic prosthesis need to be adjusted after cementation, a coping can be readily replaced with another coping by cutting the coping into 2 parts with a fissure burr prior to being removed with pliers. The following clinical cases demonstrate how these techniques can be used to insert telescopic TRINIA prostheses. Our first clinical treatment demonstrates the clinical procedures for the fabrication of a telescopic TRINIA restoration on 4 Bicon implants for a 70-year-old man in only 3 clinical visits. Restorative treatment began on the first restorative visit with the removal of 4 white transitional peak abutments and the making of a conventional full arch implant level transfer impression with green 3.0 millimeter metal impression posts and blue 2.5 millimeter metal post with their corresponding acrylic sleeves. Subsequently, an occlusal registration was made with the same metal impression posts and new acrylic sleeves. During the second clinical visit, a laboratory fabricated wax teeth arrangement was inserted with 1 impression post into the well of an implant to achieve stability while the teeth arrangement was being evaluated, and a new occlusal registration was made. During the third clinical visit, the 4 universal abutments were sequentially seated into their respective implants according to the numerical markings on the stone model and the light-cured resin seating jig, which was essential to facilitate the orientation and seating of the 4 universal abutments. Unfortunately, subsequent to the definitive seating of the abutments, the Trinia prosthesis was prevented from seating appropriately. This was due to mucosal interference caused by the inappropriate removal of stone from the working model, as well as Trinia material extending onto the margin of the milled titanium copings. Fortunately, after modifying the Trinia prosthesis to fit over the seated milled abutments, the prosthesis was successfully cemented intraorally onto the 4 milled titanium copings with resin cement and was subsequently removed for polishing. Our second clinical treatment demonstrates the insertion of a telescopic Trinia prosthesis for an 80-year-old woman during her second restorative visit. Immediately following the extraction of her remaining mandibular teeth, restorative treatment began with the removal of 4 standard profile universal abutments with their corresponding white healing caps. Initially, the insertion on the right side of 2 standard profile universal abutments facilitated by a light-cured resin seating jig, and subsequently the orientation and seating of 2 5 standard profile universal abutments on the patient's left side. After the definitive seating of the 4 universal abutments, Vaseline was applied into the bore of the 2 retentive and 2 non-retentive milled titanium copings prior to their being seated onto their universal abutments. After their seating, the Trinia prosthesis required some minor modification to facilitate its appropriate seating onto the 4 milled titanium abutments. Once the Trinia prosthesis was appropriately seated on the milled abutments, it was removed and prepared for cementation onto the 4 copings. Because of the insertion of the telescopic Trinia restoration immediately after the extraction of multiple teeth, it shall be necessary to intra-orally reline the prosthesis after a few months of use. Our third clinical treatment demonstrates the insertion of both straight and angled universal abutments and the restoration with 2 retentive and 2 non-retentive milled telescopic copings. These copings are used with an anatomic Trinia framework that has 11 units of veneering with the polyceramic material Ceramage by Shofu. Our restorative treatment began with the removal of a transitional prosthesis and its 4 supporting abutments. A full arch implant level transfer impression was made, and subsequently an occlusal bite registration was recorded using a wax rim that was stabilized with 2 green 3.0 millimeter impression posts. During the second restorative visit, a 5.0 millimeter gold-colored sulcus reamer was used in conjunction with one blue 2.5 mm guide pin and 3 green 3.0 mm guide pins to remove any tissue which may have interfered with the seating of the 4 number 5 universal abutments. Subsequent to the preparation of the sulci, 2 straight and 2 angled universal abutments were oriented and seated into the well of their respective implants with a light-cured resin seating jig, which had numerical markings indicating the appropriate sequence for the seating of each abutment. Once the 4 abutments were definitively seated, 2 retentive and 2 non-retentive milled titanium copings were placed onto them. Unfortunately, the appropriate seating of the Trinia prosthesis required some minor modification of its bores and undersurface. Additionally, its anterior pontic ridge surface had to be relined intraorally to compensate for the ridge resorption that occurred subsequent to the recent extractions of the patient's anterior teeth. After the appropriate finishing and polishing of the relined Trinia prosthesis, the 4 milled titanium copings were intraorally cemented with resin cement into the bores in the Trinia prosthesis. Our 4th clinical treatment demonstrates the fabrication of a telescopic Trinia prosthetic obturator in only 2 restorative patient visits. The patient is a 71-year-old man who has been wearing an obturator for over 46 years to cover the surgical defect left by the removal of a benign mixed tumor of his hard palate. Treatment began with the replacement of all but his 2 canine integrated abutment crowns with impression posts for the recording of an occlusal registration, and subsequently, after the removal of the canine IACs, for the making of a full arch implant level transfer impression. During the laboratory phase, the impression was fitted with 9 implant analogs prior to the pouring of a soft tissue stone model. Subsequently, the model was scanned for the initial virtual fabrication of a Trinia prosthesis, and later for the actual fiber-reinforced resin Trinia prosthesis with candelor teeth and a light-cured resin seating jig. During the second restorative visit, the light-cured resin seating jig was used to orient and seat the 9 prosthetically parallel abutments into 9 non-parallel implants. The seating jig was gently removed with a crown remover. Vaseline was applied to the bores of the seating jig to facilitate its removal. The process of aligning abutments with the jig was repeated several more times until all of the abutments were properly seated. The appropriateness of the Trinia prosthesis seating was confirmed twice, first over the abutments without copings and then with copings. After minor modifications, the appropriate seating of the prosthesis onto the 9 abutments was confirmed. Then Vaseline was applied into the bore of 3 retentive and 2 non-retentive copings to facilitate their removal from the universal abutments after their cementation. Vaseline was also applied to the underside of the Trinia prosthesis to facilitate the removal of any extraneous cement, and resin cement was applied into the bores of the Trinia prosthesis. Following the removal and polishing of any extraneous resin cement, the prosthesis was inserted and the occlusion was adjusted minimally at the end of the second restorative visit. During a subsequent visit, in order to provide greater retention, a non-retentive coping was replaced with a retentive coping. The non-retentive coping was removed by cutting it into 2 pieces prior to cementing a new retentive coping intraorally into the prosthesis. Our 5th clinical treatment demonstrates the restoration of a 70-year-old man's dentition with a Trinia telescopic prosthesis supported by 4 Bicon implants. During the first clinical restorative visit, treatment began with the making of an implant-level transfer impression and the recording of its inter-arch occlusal relationship. After the fabrication of a soft tissue stone model with 4 implant analogs and its articulation, 4 universal abutments were selected to be prosthetically parallel. The 3 abutments on the right side and their corresponding retentive copings had to be modified occlusally to accommodate for the patient's loss of his vertical dimension of occlusion. Following these adjustments, a final Trinia telescopic restoration was fabricated. During the second restorative appointment, his worn teeth were modified to accommodate the prosthesis, and the healing abutments were removed. Then, following the sequence on the stone model and seating jig, the abutments were inserted into their corresponding bores within the seating jig and subsequently placed into the wells of the implants. They were then tapped into place with a seating tip and an offset driver. This process was repeated according to the sequence designated on the model until all of the abutments were properly tapped into place. Confirmation of the appropriate seating of the prosthesis over the modified teeth and abutments was achieved with a silicone material. The prosthesis was then slightly modified to assure its proper seating. Vaseline was applied to the bore of the single coping before it was seated onto its universal abutment, and the 3 modified copings or rings were seated onto their corresponding abutments prior to the confirmation seating of the Trinia prosthesis. Articulating paper was used to confirm an appropriate occlusion, and minor adjustments were made to the bores of the prosthesis to assure its appropriate seating and cementation. Following these adjustments, the underside of the prosthesis was coated with Vaseline, and resin cement was applied to the bores of the Trinia prosthesis before it was inserted and cemented onto the milled copings. After confirmation of the appropriate occlusion and removal of any extraneous cement, the patient was given instructions on the removal, insertion, and maintenance of his Trinia telescopic prosthesis, which was fabricated in only 2 restorative patient visits. On a subsequent restorative visit, the prosthesis was relined intraorally with Ceramage for a better adaptation to the patient's existing teeth. Hopefully this video has enhanced your understanding and appreciation of how a Trinia telescopic prosthesis may benefit both you and your patients. Thank you for having watched.